I am Anil Kumar. Welcome to my series on calculus. Now, in this series, we are having word problems, worksheets, test questions, and Zoom sessions on videos. I'm also uploading related videos on YouTube. The related videos are free of charge. Now, here is the next chapter on calculus where we are going to discuss about rate of change. In Introduction to Calculus, we did find the definition of tangent line, and here we can say that gradient, slope, or rate of change are kind of wordings which are used for similar things. So we'll kind of mix and match these terms. You're very familiar with slope, which is rise over run. Gradient is the same thing, and rate of change we normally use when there are application word problems. So here we see three different graphs, and they will kind of they will actually connect us with what we have learned earlier and what we are going to learn now in calculus. So in the very first graph, we have few lines. So let me just number, rather write A, B, C, D. So let's say this is line segment A, B, and then we have from B to C, and we have here D to E. So we have three different line segments. We can actually find the gradient or slope. Let me use the term slope itself. So we can find the slope here by finding change in y over change in x. And normally we'll write y2 minus y1 over x2 minus x1 to find the slope or the gradient. Now, in case we are working with something like a circle, in that case, we know that the radius is tangent. Radius and tangent are perpendicular. So if I have a tangent at a point P as shown here, then in that case, it will be at right angles to the radius. Now, if I have to find slope of the tangent line, this is line T, the tangent line, at point P. So basically, we are trying to find the slope at point P. Now, this slope will be what? This slope will be negative reciprocal of the slope of line OP, since they are perpendicular, right? So remember, whenever you have perpendicular lines, then product of their slope is negative reciprocal. Now, easy way is, if it is given to be from the center, the point P is, let us say, x and y, correct? In that case, the slope of O to P is y over x, correct? So the slope of line, let me at P, which is the tangent line, is going to be negative x over y. Is that clear to you? So simple, right? This is for the tangent line at P. Now, in case we are working with different curves, right? Not circles, but different curves. Oh, so we took a parabola and we say, well, we could take a point P and we have a point Q here. So initially, let us say Q is at 2, 1 and 2, 4, right? And point P is at 1, 1. We need to find slope of the tangent line at P. So the idea here is we could start from somewhere like Q. So we have a secant, which is PQ. And what we do here is that we bring the point Q closer and closer to P, right? So we decrease this distance. We're calling the distance between P and Q as H. So what we do here is that we bring Q closer and closer to P. And so we say when H approaches 0, in that case, the slope of secant approaches tangent. Correct? So that is the concept of slope on any curve at any point. Perfect. And for this, we had a difference quotient equation. So let me now give you the difference quotient equation. We also call this as a derivative. So normally in calculus, we'll use f dash x. This dash is dy dx. We'll soon come to know about it. Derivative with respect to x, those are the different terms. But let me just write f dash x. I could also write gradient g at this moment. So it is basically limit for h approaches 0. And these 2 points, we are saying a, f of a plus h is the value. So if this point is, let us say, a, right? So in that case, this point value will be f of a. For a point q, which is h away, x value will be a plus h, and the y value will be f of a plus h, correct? So gradient is rise over run. So this difference, which is right there, I should say that difference, is f of a plus h minus f of a, correct? And the run is h. So we get this as f of a plus h minus f of a divided by h. So that becomes your difference quotient formula, correct? So that is how we really find the rate of change. So our focus will today be on rate of change. So let me write down the formula once again clearly here. We are saying that the rate of change, which could be gradient g, which we'll write as f dash of x, is limit h approaches 0 for the function value a plus h minus the value at a divided by a plus h minus a cancel, we are left with h. So that becomes the formula, and this is known as difference quotient. Is that clear to you, right? So that's the beginning of this particular unit, and where we'll explore many examples with rate of change. Now, I have a very different approach in this particular video since you have practiced a lot about simple examples based on rate of change. So I'll begin with some questions which you need to answer. Question number 1 here is, estimate the rate of change at x equals to 1, right? So at x equals to 1, you need to estimate the rate of change for all the following graphs. So these are the three graphs for you. When we are saying at 1 means this is 1 for you, right? So this point we are interested in. So here 1 is this point, right? So that is the value of 1. Estimate the rate of change. Here this is the point where you need to estimate the rate of change. So in the comments, you can write down these answers. We'll have a look at it. And in the Zoom call, which I'll have later today, we'll actually answer these questions. So let's now look into the next question, which is also very simple, but they are tricky questions. Question number 2 here is, the graph of f of x equals to 4 minus x squared is given below. So you know this is a parabola opening downwards, and that point right there is the vertex, which is at 4, right? So let me write big and bold so that's very clear. These 2 points here are, as you know, minus 2 and plus 2, correct? So that is the parabola, which is y equals to, or f of x equals to 4 minus x squared. Now the question for you is, which of the following statement is always true for the gradient of f of x, that is rate of change for the curve, right? Remember one thing, gradient of f of x is a function itself, right? So when we say gradient of f of x, we're talking about a function, right? It is not a point, it is not a value, it's a function. Is it clear? That is what g is. G is also a function of x. Okay, so 5 statements are there. One of them is true, right? The statements are, gradient is always increasing, gradient is always decreasing, gradient is decreasing, then increasing, gradient is increasing, then decreasing. None of the above is always true. So one of them is definitely true. you need to write down also in comments. Now let's look into question number 3, which is very interesting question once again. Determine the slope of the tangent line at the point P 1 minus 3 on the circle given by the equation x square minus 4x plus y square minus 8y plus 16 equals to 46. So let me write down this equation clearly for you right here. The equation is equation of a circle, which is x squared minus 4x plus y squared minus 8y plus 16 equals to 46, correct? And we are given a point on this circle. The point given to us is 1 minus 3. So at this point, you have to figure out or estimate the slope of the tangent line. Now, don't think estimate is a rough value. Whenever we are finding tangent or a gradient, we are always estimating. Let's be very clear about it, because the point Q, as we had just discussed here, is very, very close, but it is not exactly at 0. So there could be some error. So always we say estimate, right? So it's an estimated value. Now here is the concept for this particular question. You need to figure out what was the center of that. Then the point is already given to you. Once you find the center, you get the slope of the radius, O to P, and then negative reciprocal, you get your answer. Correct? So that is how you're going to answer this particular question based on circle. So let me write down a hint here. So hint is find the center of the circle, right? Correct? And since you know the point which is 1, 3, you should be in a position to find the tangent, right? So not much calculus is required. It is what you've already done before. Now let's take the next question, which is question number 4. Now this is, consider the rational function f of x equals to x square minus 1 divided by x square minus x. Write the number of points on the curve of f of x that will have gradient of 1, 0, undefined, or minus 1. So that is the question for you. So I hope you have understood the question. We're talking about a function here. The function is f of x is a rational function, x square minus 1 over x square minus x. Now we need to figure out how many points on this curve will have a gradient of 1. That is what the number could be, like 0, none, 1, 2, whatever, right? So you have to find how many. So one way could be that you may sketch the graph. So you may sketch the graph and answer the question. Perfect. And then answer. Now, you may have points where the slope is undefined. You may have points where slope is 0. You may have points where slope is minus 1. Or you may not have any point with those slopes which are given to us. So, critically analyze this particular function, you know about it, sketch it, and then answer this particular question. Perfect. So that's kind of a review of what you have already done, and I expect you to provide me with these answers very easily, right? Now, let's look into rate of change applications. So really speaking, when we move on from difference quotient equation to rate of change, we kind of apply it to different kinds of situations. Question number 5 is a good example on this. So we'll solve this particular question now. It says, the temperature T in degrees Celsius varies with the distance d in kilometers above the Earth's surface according to the equation T of D equals to 60 divided by D plus 2. Determine, two parts are there. The average rate of change, we'll write it as ARC, average rate of change, in temperature with respect to distance between 3 kilometer and 8 kilometer. And part B is instantaneous rate of change in temperature, IRC, with respect to distance at 3 kilometers, right? So those are the two questions for you. They're relatively straightforward. So we are given that the formula which relates to the temperature with the distance from the Earth's surface is given as 60 over D plus 2, correct? So to find the average rate of change, what are you going to do? So A is average rate of change, right? Average rate of change will be between, we want 3 kilometer and 8 kilometers. So in that case, you can say difference of temperatures. You can calculate the value between when distance is 8, when distance is 3, divided by 8 over 3, correct? So plug in 8 here and 3 there, right? So we get temperature. When you plug in 8, it will become 60 over 8 plus 2, minus, when you plug in 3, it will be 60, 5 plus 2, correct? And you know here we have 8 minus 3, which is 5. Easy calculations, so you can provide the solution right there, correct? So you can calculate this, but don't forget to write the units. Units are very important. It is degrees Celsius and per kilometer. So include the units, which is degrees Celsius per kilometer. Is that clear to you? Perfect. Now that is how you're going to do part A. Now as far as part B is concerned, you'll apply the instantaneous rate of change formula. So we'll write this as instantaneous rate of change, where the limit will be h approaches 0, correct? And the function, we want it at 3 kilometers, correct? So we'll write f of, rather, the given name is t, so maintain this name t. So t of 3 plus h minus t of 3 over h. So that is what you need to calculate, and you are given a function right there, which is a rational function. So that should help you to work out the solution. Again, the units are known to you, right? Now here, what I did was that I actually typed out the solution for you. So here is the question for you, question number 5, and straightforward solution to average rate of change is given to us right there. So we have the solution. We're saying that temperature when D is 8, calculated the value as 6, and when it was 3, the value is 12. So substitute 6 and 12, 8 and 3, minus 6 divided by 5 gives you minus 1.2 degrees Celsius per kilometer. So that is how you could find the average rate of change, correct? Now have a look at the instantaneous rate of change, which is clearly, we have applied this particular formula, which you are now familiar with, difference quotient formula. So instead of H, I'm using delta D. So H and delta D is one and the same thing. So we are saying delta D is approaching 0, right? So in many conventions and many schools, we are using delta T, delta X, or delta D in this case to solve such questions, right? So D plus delta D minus T of T over delta D. So when you write d plus delta d, it really means that in the basic formula, replace d with d plus delta d, right? So d plus delta d plus 2, and then you just work out as shown here and work out all these steps, and you get your result, which is minus 2.4. So that becomes the instantaneous rate of change. So remember, in any equation, if it is rate of change, it means instantaneous rate of change, correct? That's kind of very important to understand. So the instantaneous rate of change is given to us. So I hope this solution is absolutely clear. Now let's move on to the next question. You can actually pause the video, go through it, and then whenever you feel convenient, move to the next question. The next question, which is question number 6, is again a very important example. We are saying find the gradient function for the curve f of x equals to 25 minus x squared. Now, can you sketch this function? F of x equals to 25 minus x squared. How will this function look like? That's kind of important to understand, right? So let's say this is our x and y axis. If I have to sketch this, this is actually a semicircle, right? So it is a semicircle where the x values will be plus and minus 5. So we are looking into this particular case. If x is 0, square root of 25 is 5, so this point is 5, and that is how the function is going to be. Correct? Now we are saying find the point on the curve square root of 25 minus x squared where gradient is minus 4 over 3. So definitely if it is minus, that means line is coming downwards. We are expecting somewhere there, right? So that is kind of a place. So you're looking for one solution. So when you read it clearly, you get an idea where the point is going to be. Perfect. Now, so it's not very difficult question. Now you can figure out that you can easily find this particular point even without doing calculations, correct? Since we learned something about circles and semicircles, let's visit that place once again. It's always important. If you get this question in multiple choice, then you have your answer right there, right? Because this point is at 90 degrees, right? That's the semicircle we are talking about. Is that clear to you? So that is what the question is. And the situation is very similar to what we are looking here on this page. So I hope you get the concept, right? So basically, that is what kind of situation is. But the question is framed in a way that you have to use difference quotient formula, right? So it says find the gradient function. So when you say find the gradient function, we're not interested in the answer. We are interested in what is g equals to, right? What is g? That is the gradient function you have to find, correct? So you have to begin with limit h approaches 0 and f of, let's say, a plus h minus f of a over h, and then do all the calculations and then get to the result, right? So first and foremost is part A, which forces you to do the complete calculations, and after that you can always find the point. That is a simple part, right? Okay, so that's kind of critical. Now here is the solution of this particular question. So I thought I'll just share with you the solution straight away. Now we have the question right there. Now the solution begins from this place. So we know that the gradient is what we need to figure out. So what we have done here is, let me just push this a bit. Okay. So let's look into the solution now. Here is the full solution visible on your screen, I hope. So gradient g is limit h approaches 0, f of x plus h minus f of x over h. So now the function is given to us 25 minus x squared. Replace x with x plus h. So it becomes 25 minus x plus h whole square minus f of x is the function itself divided by h. We need to now rationalize it, correct? So the key is whenever you have this kind of thing, you have to rationalize, correct? So once you rationalize, then we get a simplified form since we know what is a plus b times a minus b equals to. That is a square minus b square. And therefore the radical sign vanishes, right? So here we don't have the radical, we only have the radicand which was inside, correct? And now 25 and 25 cancel, And we have a much simpler equation right there where h is common. So it cancels with the denominator. And so once you cancel that h, taking it common here, right? So we just extended the calculations as shown. You get a simplified form. After cancelling h, we need to substitute h equals to 0. And once you do that, you get your result minus x over square root of 25 minus x squared. Is that clear to you? So have a good look at it. You can actually pause the video, do it yourself. This is extremely important question. I like you to practice similar questions as semicircle is one of the most important function in calculus which is always seen in the test papers. So in functions so far, you were not given questions based on semicircle, but in calculus, you should expect it. Now part B is find the point on the curve where the gradient is minus 4 over 3. So now, once you know the equation gradient, right there, now the gradient is known to you. This is your equation. Substitute minus 4 over 3, cross multiply, square both sides. Now remember, here is a very, very critical step which I want to explain to you. When we write this statement, in that case 3x is positive because square root is always positive. So this is right, left side is positive, so right side is also positive. So when you do square root, remember when you do square root in further calculations, you have to take the positive value only. Perfect. And that's the reason, right? So once you get the gradient, equate the gradient as minus 4 over 3, cross multiply, square both sides, square root, and get the value of x. Once you get the value of x, substitute the value of x to get f of x. In this case, x came out to be 4. And then you get 3 as your answer. So as I was suggesting, you can correlate this answer with the point. So if it was a multiple choice question, this was a very straightforward thing. And that could have saved a lot of time for you. Perfect. Now, let's take some application questions which are typical of rate of change. Now, previous questions which we looked into are very important test problems. You may like to go through this video once again to understand what we have done so far. Question number 7. This is relatively a simple question, but always seen in the test papers. Question number 7 is, a pebble is dropped from a cliff of height 180 meters. After t seconds, it has fallen a distance of s meters, where s of t equals to 5t squared. A. Find domain of s. B. Find average velocity of the pebble in the second. C. Show that the average velocity of the pebble during the time interval t equals to 1 to t equals to 1 plus h is 10 plus ht. And D is find instantaneous velocity of the pebble at t equals to 1. Justify your answer. Now it's important to understand that we are given the change in height. So height is like a position, right? So think like this, that's the top from where the pebble is being dropped. So the pebble is just coming down like this. What we are given here is that the distance which it covers, s of t, is basically equal to 5 times t squared. So that is the relation given to us. Now when we are saying find the domain of the function, it means what? It really means we need to figure out when will the pebble hit the ground. But once it hits the ground, the distance is not going to change, right? So that's the end of it. Perfect. So that is what we need to figure out. Now the equation is, let me write down here and then we'll work it out. We have s of t as equal to 5t square. And total distance, the height given to us is 180 meters. So substitute this s of t with 180. So we have to travel a total of 180 meters equals to 5t square. So we get 180 divided by 5 as equals to t square, correct? Now, bringing it to the right side, we can find what t is. So t will be square root of this, but let me simplify this. So 5 goes uh, 3 times and 6, so that is t square. T will be square root of 36, which is t equals to 6 units of seconds. So the domain for us is t, correct? So domain for us is the value of t, which belongs to real numbers. You can write in the set form, and it is equal to greater than equal to 0 but less than equal to 6. Is that clear to you? That is the domain. We don't have to find the range, but the range will be from 0 to 180 meters. Perfect. Okay. So we have done part A for this particular question. Part B is find the average velocity of the pebble in second. Now this term is also very confusing. What do you understand by second? Why? What should I do? Okay, think like this. Think like this. We say first, second. You understand? First second means t equals to 0 and t equals to 1. That is your first second, right? And when it goes from 1 to t equals to 2, this portion is your second. Does make sense? So when we do part B, we're saying second, right? So it's not a mistake. It's kind of a confusing word, but right. So we are saying time 1 is 1 second and time 2 is 2 seconds. So it is the second, right? So those are the two things, and you need to find average rate of change, correct? So average rate of change, we are at A or C, will be S of 2 minus S of 1 over 2 minus 1. Is that simple, right? So just plug in 2 here, so we get 5 times 4, which is 2 square, minus 5 over 2 minus 1. So it is 20 minus 5 over 1, which is 15. And this displacement is given in meters, right? So meters per second. So that is average rate of change. So whenever there's a rate per unit, second in this case, right? Now, part C is show that the average velocity of the pebble during the time interval t equals to 1 to t equals to 1 plus h is 10 plus ht. So let's move on to a fresh page to do this. So here we have the same equation. So we are now working on this particular part, which is average rate of change, right? So average velocity for these two times. So let's write down again the average velocity. So average rate of change, and the time is from 1 to 1 plus h. So we'll write this as s of 1 plus h minus s of 1 over 1 plus h minus 1, right? So that is what we're going to write. So s of 1 plus h, s is 5t square. So it will be 5 times 1 plus h whole square minus 5 times 1 over h. So we can now expand 1 plus h whole square, which gives us 1 plus 2h plus h square minus 5 over h. Now 5 and 5 cancel. So always it is going to cancel. Remember that part. If it doesn't cancel, that means something went wrong in your calculations. You have to take care of it. Now we can open the bracket. So we get 10h, right, plus 5h square over h. And we're closer to it. We can just take h common. So we get h common. We get 10 plus 5h over h. So we can now cancel h and h. And what do we get? We get the result, which is expected, 10 plus 5h, right? So that is the average rate of change which we have calculated. So that is all which is required in this particular question. Remember, velocity is average rate of change of position. Now position could be distance or height, okay? So we've done this part. Now the last part is find instantaneous velocity of the pebble at t equals to 1. So when we say instantaneous, what does it really mean? So instantaneous rate of change is what? It is only the limit when h approaches 0 for average rate of change, correct? So we can write this as limit when h approaches 0 for 10 plus 5h, and that clearly when you substitute 0 for h is 10. So we get that instantaneous rate of change, and that should be in meters per second, right? So both are in meters per second, and that becomes your answer. Clear? The last question here is, a spherical balloon is inflated. Question 8a. Show that the rate of change of volume with respect to the radius is related with the surface area of the balloon at that instance. And 8b is, find the rate of change of balloon when the radius is 10 centimeters. So now this is a very popular question. We are saying volume of a sphere. So volume of a sphere is 4 by 3 pi r cube. That is what it is. We need to find instantaneous rate of change. So we can write v dash here will be limit h approaches 0 for 4 by 3 pi r plus h whole cube minus 4 by 3 pi r cube, right, divided by h. That is what it is going to be. Now to solve this, you should know the expansion for r cube, right? R plus h whole cube. So if you don't know the expansion, in that case, you could also use Pascal's triangle. So let me just say Pascal's triangle. I'll just quickly make one here. So that is how you make Pascal's triangle, correct? So add the previous two to get the next one. 1331 is the coefficient, correct? So now we'll use this Pascal's triangle to expand. And of course 4 by 3 pi is common. So we can write the constant 4 by 3 pi to start with. Because when we are taking limit h approaches 0, this constant is independent of h. So it doesn't really matter, right? Here we have, now we'll expand this part. We have r cube, right, plus 3 r square h plus 3 r h square, right, plus h cube minus. We took 4 by 3 pi common, so minus r cube over h. Is that clear to you, right? So r cube and r cube cancel. What we are left with are terms in which you can take h common and then h will cancel, correct? That's the whole idea. 4 by 3 pi limit h approaches 0, take h common, right? You get 3r square plus 3r h, because we took h, 1h common, plus h square, correct? Divided by h. And now h will cancel. So we are left with a very simplified form, which is 4 by 3 pi, and we don't have any h in it. We'll write limit h approaches 0. The terms are 3r square plus 3r h plus h square. No h in the denominator, I mean, right? So that cancels, it's just 1. Now, if I substitute 0 here for h, what happens? If I substitute 0, these two terms approaches 0, we get 3r squared. So we can now write down the expression as 4 by 3 pi times 3r squared. Now 3 and 3 cancel. And what do you get? We get 4 pi r square. And that is the surface area, correct? That is surface area. So at any instance, rate of change of volume is same as surface area. So this is a very important formula. So we can say rate of change of volume equals to surface area. We're talking about the values, right? Only values, right? Okay. So that's what you get, 4 pi r square, and that's it. So we got the first part where the hint was that these two things are related, right? So they're same values, okay? So that's what we get. Now, let's look into part B, which is find the rate of change of balloon when the radius is 10. So just plug in 10 here, correct? So we get the value of rate of change for 10 will be 4 pi 10 square, correct? Which is 100. So we get 400 pi. You could also multiply by 3.14 and get your answer, but that's good enough. So and the units will be centimeters, I think we're talking about. Rate of change with respect to instance radius, right? So the volume is a centimeter cube, and we differentiate it with respect to r, so per centimeter. Do you understand? That is how we are going to write the units. So this was, we are finding rate of change with respect to radius. So therefore the units are this, right? So remember, we are saying rate of change with respect to radius. Perfect. And we get this answer 400 pi centimeter cube per centimeters, right? So that is where we complete our video on this. I hope you've understood all the concepts about rate of change. So we began with basic understanding, which was developed in the previous lecture about difference quotient, right? So the last graph here shows clearly what we did, right? Those are the old things which you know about, and we just connected them all to move into calculus. And one by one, we took few questions, but I left three for you to answer. Now, these are the questions which you should be answering. Very simple. Within a second, you should answer these things. And the second one and the third one, right? So the idea is this is what you had been doing earlier. And later questions, we have provided you with the solutions. Now, the rational function, you should sketch and then answer this particular question. Write down in the comments, and then we will discuss this in details, right? Now, as a hint, what I can also say is you could simplify the function itself. So you could write this as x plus 1 times x minus 1 over, we can take x common, x minus 1. And now many terms will cancel, and therefore you can write down the restrictions and sketch your graph, right? So you could now easily sketch your graph from the given conditions. So that will be a kind of hint for you, and you can then answer all your questions. Then we took up application questions based on temperature change with height. It had a complicated solution, and that was the solution for us. And I hope this really helps you to understand how to deal with the situations where we have rational functions, correct? So whenever you have rational functions, in that case, it is good idea to take a common denominator and simplify. And then we had a semicircle question, which is a very popular question in most of the test papers. The solution was also provided to you. And then we worked on two more problems, which were based on the stone thrown. Now that is a common test question, and a shape we took, in our case, a sphere, We could take some other shape also and work with the rate of change of volume or water contained in them, right? So those could be some other interesting questions. I hope it makes sense. Feel free to write your comments, share your views, and keep looking for our Zoom sessions. And if you want to join, you can always send a request on my email address. I'm giving email on all the papers sharing with you. That's my email address. And then we can discuss how you can also join us. Thanks for your time and all the best.